Hi guys, in this session you are going to learn about the data visualization using R programming language. So R also supports different kinds of graphs like pie charts, bar charts, histograms and etc. And once you explore your data, you can save the graph in different formats like PDF, PNG, JPG, WMF and PS PostScript. So it is very easy to plot a graph and then save it in required format. So this session describes how to do the data visualization using R. So R comes with predefined data sets as well. So in order to know the list of data sets which are part of R, so we can execute the method that is data. So let us say uh, let me open a script file. So here I am already having. So let me run the function. So data, simply calling the data method, so which lists out the set of data sets. So here we have the list: 8 passengers, so carbon dioxide, BO CO2, and you have even orange Titanic data as well, and you have US arrest, which is nothing but the criminal activities in different states of the America, and you have other data like cars and iris. So you might be familiar with iris. So these are the data sets. So we are going to use a couple of the predefined data sets, and then we'll be learning the plots, how to do the plotting. So if you want to learn any specific data, then you need to write data of empty cars. Then it will load the data and it creates a data frame. So you see data is loaded, and then if you write head of empty cars, it will show you the data. And in the environment part, you can see empty cars is the data frame name, and which has 32 observations and 11 variables. And it is very important to know the details of this data set. So for that, we can also take help, right? You can just search for empty cars. You can take help on empty cars. So let us understand this data set. So it's a data set collected from 1974 Motor Trend US magazine, and um, there are 32 automobiles. So you can see the 32 observations means 32 rows, and 11 variables means 11 columns. And what are those columns? The columns are these: MPG, which stands for miles per gallon, number of cylinders, CYL means number of cylinders, displacement, horsepower, draught, weight, quarter per second, engine type, VS means engine type, which has two unique values. So 0 means V-shaped and 1 means straight. And you have AM, transmission type. 0 means 0 means automatic and 1 means manual. And gear means the number of forward gears of the car, and carb means number of carburetors. So these are the variables, 11 variables in the data set. So we'll use this data set and we'll try to plot a few graphs, right? So you can specify the name of the data frame, then name of the data set, then you can load it, and then the data frame is created. So after having familiarity on this data set, so we'll see what are the different types of graphs can be plotted. So here I've listed some important graphs like bar charts, pie charts, histogram, kernel density plot, and line chart, box plot, heat maps, and word cloud. So let us see how to do the plotting. So the first one we consider is bar charts. So as you know, bar charts are used to show the comparison between the categorical variables, right? You can show the comparison between the categorical variables, so which represents the length or the frequency or the proportion of categorical values. So the function used to plot the graph is bar plot of x. Then what is x here? X is your data sets. You need to supply the proper data sets. So let us see how to do the bar plot. So here no, what I'm doing is the gear from the empty cars of gear. So we're accessing the gear column, then having a table, then it retrieves the count, and that count is stored into the variable count, and then I'm printing the count of the gear. So what is get? Get means the number of forward gates. So there are three values, three unique values for this: 3, 4, 5. So the count of 3 is 15 here, and the count of 4 is 12, and count of 5 is 5, right? So after getting a count, then we can give it to the function, that is bar plot. Then we'll be having the bar chart on the count. So in the plot environment, in the plot tab, you can see the bar chart. So this graph is called as bar chart. On x-axis, you are showing um, the bar number, right? 3, 4, 5, three unique values. For this, what is the frequency or the count, which is shown on y-axis? So the count of 3 is 15, so which is shown here. The count of 4 is no 12, and the count of 5 is 5, right? So this is the simple bar chart, and here the color uses this, but you can also change the color. So if you want to take help on this function, you can do that. Question mark bar plot of this, then we're having a no help on that. You can better use also double quotation, right? This is the description on the function. You can just go through what are the functions that I mean, sorry, what are the parameters, I mean arguments, and then what is the description or meaning of these parameters. You can see that with examples. And so this is the vertical bar chart, right? This is by default vertical, and you can also have horizontal plot. So in order to have that, you need to write the parameter horizon is equals to true, so which gives the horizontal bar chart. So on x-axis you have the frequency, and on y-axis you have the um, the label, right? There are three types of gears, 3, 4, 5, and we have three bars. And for those three bars, if you want to have a different colors, you can also do that. You can specify the parameter COL, which means the color, and here we are creating a vector of three colors: red, yellow, green. And whenever you say figure means having the title. So main is equals to simple bar chart, means this is the title. X lab, x-axis label, y lab, y-axis label. And we can also add a legend means description of a particular bar, which is equals to row names of count. That means 3, 4, 5 are going to be the legends. So when I run this, you can say this is the bar chart. So our x-axis label is improvement, and y-axis label is frequency, and the title of the figure is a simple bar chart. And you can also see the legend, this box. So the frequency, the red color is representing the no the count 3, the frequency is 15, like this. So this is a simple bar chart. We have added the titles, x-axis label, y-axis label, and then legend is also added, and then we have also changed the color, right? uh, Bar chart can also be used, no, you can also have a stacked bar chart. So here I'm taking a count is equals to table of taking one more variable, that is vs, means engine type, and getting the count of this. So you can see the count of 3 is 15 actually, which is distributed into three types: 0, frequency is 12, 1 is 3. Similarly, the count of 4 is 12, so 2 plus 10. Count of 5 is 4 plus 1. And on this we can have a bar chart. So bar plot of the count is the data, this is the title, and x-axis label is there, y-axis label is there, frequency, then color used is 2 because you have two bars here, and legend is also added. So this is the stacked bar chart, means you'll be having a no another bar one top of another bar. So 0 plus 1, so 12 plus 3 total is 15. This one is 2 plus 10, 12. This one is 4 plus 1, 5. So this is the stacked bar chart. Next, if you write beside equals to true, then side by side, you're having the bars side by side. So this is the only difference. Beside is equals to true. So the frequency of 0 type and frequency of 1 type, so they are shown side by side. So these are the variations in the bar chart. and I hope you got the meaning of bar charts. Next, we can also have pie chart. So we'll take a sample data here, and we would like to have a pie chart. So pie chart shows the distribution of the data out of 100%. So you can have a circle which is divided into cells, each cell representing the proportion of value of the whole. So we are taking a sample data here. So let me open my file. So slices, so 10, 12, 4, 6, 8, and the label of these like US, UK, Australia, Germany, India, and then the pi. Pi is the function. It is taking the data, that is slices, labels equals to labels, and main equals to title. So this gives us the simple pie chart. So this is a pie chart. So the highest value is for which country? Germany, 16. And in a pie chart you can also show the percentages, so that can also be done. So we are calculating the percentage here. PCT equals to rounding the value of slices divided by sum of slices multiplied by 100. So this gives the percentage, and then everything is same as we did before, but we are adding the name space then percentage symbol, right? So you can see the formatting here, paste function, country name is shown, and then space, and then the percentage value, and then the symbol percentage. So this gives the pie chart with the percentage, right? You can also add colors. The color is rainbow of 5, so 5 colors of rainbow theme are selected here. You can also have 3D graph, 3D pie chart, but this is possible after installing the library Platrix. In my case I'm already having, so not going for installation. Then the things are same, but there is only change in the function, that is pi 3D. So normally it's pi, then if you want to have a 3D chart, then 3D pi. So this gives the 3D view of the chart. So you can see the output here, and then you can also have explode. Explode means the gap between the cells, right? The gap between the cells. This one is without explode, this one is with explode. Let me run completely, and this one is with explode. I think it's not shown, something is wrong here. Let me clear the figure. So this is a pie chart. So explode also we have mentioned over here, and here also explode. The difference is, what is the difference between the previous one and this one? Change of, you can change the explode values. Let's make it 0.01 only. The gap is reduced, right, like this. So this is the 3D pie chart. Next we'll see the histograms. So histograms are the graphs which are used to show the distribution of continuous values. Continuous value means the value which has a range. So the function is hist, then x means data. So let's take an example for this. So I'm plotting the values, getting the values of MPZ from the empty cast data, and then hist of empty cast of MPZ. So this gives the histogram on the MPZ values. So this is the histogram. Break means you can have the gap between the cells, so depends on this. The breaks are adjusted, and I have used the color green here. So if you reduce the number of breaks, then the figure may change. It has changed. you can take help on this histogram, what are the parameters and all. So depends on the bars, you can also have use some colors. So I'm using red, green, blue, yellow and violet. Then the breaks are 10 and then colors equals to colors. So this is I think I didn't run this. So this is the histogram, and if you remove the break then the figure will change from the same. So this is the histogram. The next kind of graph we would like to have is line chart. So for line chart you need to specify the coordinates, x-axis, y-axis. So line means connecting the values, so we can have the line chart. Where is that? So I'm taking some sample data here. The first is weight, which is a weight vector in which specifying the no weight of the baby, and then months 0 to 9, and plotting the graph. So on months and weights, type is B. B means you'll be having the point and the line, both are shown, and this is the title of the figure. So this is the line chart. Baby weight chart is the title, x-axis label is months, y-axis label is the weight. You see, as the months increase, the weight has been increased. So type equals to B means you will be having the point here, point and line. When you say P, P means only points. Okay, P means only points, and L means only lines, right? And you have other type values like O means overlapping, right? The point and the lines are overlapped. Next is next you are having C. C means the no C means the part of the line, right? The part of the line, like this was the previous one, you have seen the lines. And then S means stair step, H means like histogram, and this one is N means no plotting. So we simply have the graph without plotting, right? So this is about the graph. We can also have multi-line graphs. So taking a vector here, v equals to this set of values, and then t is the set of values, then having a plot on v, type is O, and color is red, the x-axis label, y-axis label, the title. On top of that you are adding a line. So this is a figure with two lines, multi-line. So this is about the line chart. Next we can also have the kernel density plot, so which also shows the density of the data. So we are having the density of empty cos of MPG. This function computes the density and then having a plot, simple plot on this. Then this is the graph. So more densities are between 18 to 20, and on this we would like to have a polygon. So this part should be filled with the colored polygon, then having a figure over here with the sky blue as the color filled. So this is the density plot, and you can also have the box plot. So box plot represents these four things: minimum value 25 percentile, which is also known as first quartile; median means 15 percentile; third quartile 75 percentile; maximum means 100 percentile. So let's take an example for this box plot. So here I'm taking sample data and getting the summary of that and having a bar chart. So this is the box plot, and variable equals to true means the figure is adjusted. If you do not write variable equals to true, then the figure is adjusted to the center. That is adjusted to the center. So summary, minimum is 10.40 and maximum is 33.90. Then having a plot on this, so the figure is adjusted in the middle. And similarly, if you write variable width without variable width false, then this is the figure. So this box is nothing but the box plot in which these five things are shown: minimum 25%, 50, 75 and 100. Next we'll be having a graph that is heat map. So heat maps are having the colored values. Heat maps are nothing but colored values of the correlation between the variables. So higher color means higher correlation value. So let's see that heat maps. So we are doing this on the data set, that is a empty cast data set. So the so scaling the data here, getting the data and then scaling, then matrix. So data is scaled. Now having a heat map on scale, the row is NA means not visible, and column is there, and then scale is no because we already applied the scaling. Then heat map scale, then we remove this rows and NAs, then it shows you the dendrogram. So these are the dendrogram for row and column. So next so when you do this, this is the heat map. You can zoom it and you can see more dark color means more value. Next we can also have word clouds. Word cloud means the cloud of words, right? Cloud of words. If the word is having larger frequency, then that is represented with larger font size. Let's take an example. So word cloud. So here you can take some sample data and create a text file, and we read the data and then create a word cloud. So we require this library TM for text mining. So this is what is snowball C for text stemming, word cloud for generation, and package. This one is a R color viewer to select the colors theme. So in my case, I'm already having this. So just running, and then we want to read the text file, right? You have to specify some text file. So it shows the dialog box from which you have to select the file. In my case, let me select I have a data set modi.txt, right? The file is selected, and once the file is selected, you need to do the text processing, like here using the function content transformer, defining a function applied on the text, and if you have spaces then they can be removed, and then this slash at the rate double slashes. So if you have these things, so you can remove them. Before that, the text has to be converted into the corpus. Corpus means set of documents. So these steps are applied, and then we are doing the text mapping here. Based on the content, you can have different colors, and then text map with the, if you have the text, then that should be converted into lowercase because capital and small makes the difference. So removing the numbers as well because we want pure text. And then having if you have here, see, this is the fundamental of NLP, and every language has stoppers, so all those stoppers must be recognized and ignored. So we are removing the stoppers of the English language. Then this is the function, also removing the words like blah 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 blah. So when speaking in the speech, you can find this. Then removing the punctuations here, removing the lines in white spaces, then applying the text mining, right? So extra white spaces are removed. Then this is the creating term document matrix, which shows the term and then the frequency of that. So DTM is a user defined variable. DTM is equals to term document on the docs, and then converting that into matrix, then sorting the values based in descending order. Decreasing true means descending order, then creating a data frame with the word and then the frequency of that, then displaying the top 10 words. So these are the top 10 words. New is having the count 5, then next country is 3 times, like this. So once the data frame is created, you can just pass that to the word cloud. So setting the seed value here 1 2 3 4 for reproduction, then words equals to d of means data frame of accessing the column word, then specifying the frequency. Minimum frequency is 2, maximum frequency is 200, and random order is false, and rotation 0.35. The color theme is also mentioned. So this function will give us the word cloud. Understand, this should give us the word cloud. Something is wrong here. I missed one bracket. So while selection, so let's say this is the word cloud. Understand, this is the word cloud. Then also have the frequency, the bar plot on the word, and then what is the frequency. So these are the words. The top is new, the frequency is mentioned here, next is country, next is this one. So this is the these are the top 10 words which are frequent. So more information, you can take help word cloud of this, then we'll be having a histogram, sorry, we'll be having a description for this function. You can check the parameters. Like this, you can select any file. In my, let's say I'm selecting another file here. So I have a Modi text. This one, selecting the file. So this file is having the speech of Narendra Modi, the Prime Minister of India. Then the text has to be converted into lowercase, remove extra space, identify the stop words and all. Then once the data is processed, then you can go for creating a word cloud. I just run these steps in sequence. So the new word is this, the same, right? You can increase or decrease the fonts, the number minimum frequency. Let's make it to 1. This is with 1. This is the graph. You see minimum frequency, the number of words are more. Right here the number of words are more. Out of this, the top word is new, next is country, next is this the independence, country, main, day and all. So that is a word cloud. We have restricted the number of words with the condition minimum frequency is 2, maximum frequency is 200. This one is without min frequency 2, maximum was 200. So there is a change. So like this, you can have any text file, and then word cloud can plot the words with the larger frequency. So these are the graphs. So I tried to explore these graphs in this session, like pie chart, bar charts, histogram, right? This one, bar chart, pie chart, histogram, KDE, line plot, box plot, heat maps, and board cloud. So these are the important graphs which are used in data exploration. So once the graph is plotted, you can save that into different formats. Understand? You can save that into different formats. Like for example, after plotting this graph, you can click on export, and you can save that as image. When you select save as image, here also you can specify the image format, whether PNG or JPG or TIFF or BMP or this one. So these are the formats supported, and then you can also change the directory and file name, and then click on save. Then the file will be updated. And you can also save the export the data into PDF, means the figure is saved in PDF format. You can copy it to the clipboard and paste it in some other editors. So this is how the data is, how the figures are saved. Right, and you can also graphically mention, you can apply these steps like JPG, saving the figure in JPG and writing some logic here. So having a bar chart, then the device dot off, which returns the control back to the terminal, means the screen will get refreshed. So this is how you can save the output in a file. This is the programmatical way. Otherwise, the previous one I showed is clicking on the button, like, and this one I showed you exporting and saving. So in this video we have learned how to do the data visualization using R programming. So if you have any questions on this particular topic, you can reach out to us. So do subscribe and follow up so that you can get the updated videos in the near future.